Welcome children. So we are back with videos on Pythagoras theorem. This time we are going to do type 4 questions from our website examprep.world, and these are questions which are little advanced applications of Pythagoras theorem. Basically Pythagoras theorem is the simplest thing, but when you apply in different context it becomes different. So let us try and explore what kind of questions they can ask in exam. Okay. So we begin with first question. They have given two circles. One is radius is 4, another is smaller with 3, and the common tangent line is 10. This line is the common tangent to the two circles. Find the distance between center to the nearest millimeter. How do we do this? Because they are asking distance between A and B, let us join A and B. Okay. Let me first make this radius, and let me make this radius, and let me join AB. Now see, this is 3, this is 4, and this is 10. So if I draw one more straight line here, so this will be 3, this will be 1, right? I will redraw this thing set up here. So it is something like this. This is 4, this is 3. So this part is 3 and this part is 1. Something like this. I hope you understood, right? So these are the two centers, A and B. Now, how much was this? 10. So this is also 10 and this is 1. 3 plus 1 is 4. Now, this is 90 degrees. AB is hypotenuse of the small triangle. So go ahead. It is 10 square plus 1 square, which is root 101 meters, because the units were in meters, so it is root of 101 meters, 10.01. Okay. If we want the exact decimal, let's calculate and put it. .04 04 meters. Done. It was easy. So in this diagram it was a little difficult to explain what was happening. So here I have redrawn the whole thing without the circles, and now you have understood it. Clear? So shall we go to the next question? Let's do that. Here again there are two circles, but the tangent is diagonal. And what all things they have given? So this is 4 centimeters and this is 2. Find the distance between the two. They already told the distance between the two centers is 8. This whole thing is 8 from A. Let us write this as A, and let us write, oh no, already A and B is already here. So let's write C and D, and I will write E over here, the point of intersection. Okay. Now the diagram is complete. We have to find the length of AB. How do we do that? Remember one question we have done where we were using similarity. Are these two triangles similar? Yes, they are similar with AA property. What are those two angles? See, these angles are vertically opposite angles. They will be equal, and both are having a 90 degrees. The circle theorem tells you the tangent and the radius at the point of contact is exactly 90 degrees. So we have by A, these two are similar. Now let us write, if this is 8, I will take ED as x. So this becomes 8 minus x. Correct? Now let us apply similarity system. So x upon 8 minus x, x upon 8 minus x equals to 2 upon 4. 2 upon 4. The proportional sides I have written in the same proportion. And then cross multiply. 4x equals to 16 minus 2x. 6x equals to 16. X equals to 16 over 6. 2 8 times, 2 3 times, 8 by 3 is x. Now if it is x is 8 by 3, can I find EB? X is 8 by 3. Now look at this. Once again I am going to draw this. 90. This is D, B, A, C. Here this is 90. This is 8 minus x, and this is x. This is 2, this is 4. Now this point was E. How do I find E? I have to use Pythagoras. 8 minus x, first we will write what is 8 minus 8 by 3. 8 minus 8 by 3 is this value, and x is just 8 over 3. So we will put some values there. 8 minus 8 by 3, how much it is? 8 minus 16 by 3, which is 5.33. This is 5.33 and 2.66. This is 2.66. So we have hypotenuse of this right angle triangle, we have hypotenuse of this right angle triangle. We can find the unknown side. So AE will be equal to root of 5.33 square minus 4 square, which will give you this side, right, minus 4 square. And then similarly BE will be equal to 2.66 whole square minus 2 square. So we get two values, we add them to get the length of AB. That's it. So let's go ahead and do this. .52 and 1.75. When you add them, it is 4.27 centimeter, because everything is centimeter. So the length of the common tangent is 4.27 centimeter. Understood, right? So if you want, you should do on yourself, do it on the notebook, take pen and paper, write it. Unless and until you do on your own, understanding will be a little difficult. Okay. So my suggestion is, whatever I am doing on board, you should do parallelly on your notebooks. Okay. Let's move on to the next question. Oh, this is aircraft hangar. So hangars are made like this, so they can park aircrafts inside. Now this is a shape. Now the diameter of this is 40 and the depth is 50 meters. A helicopter places a cable. Helicopter, human can also place. How the cable is done, you know, it is starting from pulled tight and pinned on the opposite corner B. From A, outside the cable is going, and they are putting it to B. Why that cable is done? The guy who framed the question only knows. I don't know why will somebody put a cable or a rope tying from point A to B diagonally. Okay. But anyhow, we have to find the length of that cable, this cable. Okay. How do we do this? So this is circular thing, isn't it? It's a circular thing. So basically we want to know what is diagonal. AB is diagonal of a rectangle. If I open this circular thing into a flat thing, circular thing into a flat thing, it will become a rectangle, isn't it? Suppose, so this is circular thing, the width is 50. This thing will become width. If you open this circular sheet, open it, it will become a flat sheet. This is 50. And what will be this length? This will be half the circumference, so this is 20. So this length is 2 pi r is the complete circumference, so pi times 20 is the length, right? You are understanding this one? I will show you. Look at this paper. This is the dome. They are trying to put a cable from here to here. So when you open the dome, basically it's a flat square, right? So if I keep it here like this, see, so this part is 50, the width is 50, 50, and this part is the circumference of the circle, this part. So we have the radius. So 2 pi r is the circumference for the whole circle, it's only a semicircle. So it is pi times 20. Now what is AB? AB was nothing but the diagonal of this C. This rectangle AB will be diagonal of the sheet, right? So with Pythagoras, and you have a 90 here. So this is A and this is B. See, in these kind of questions, you need to have power of imagination, imagining 3D structures and then disintegrate them into small parts and then calculate. Now from here it is simple, Pythagoras theorem. So AB will be equal to, because that's the hypotenuse, root of 20 pi whole square plus 50 square. And our calculator will help us to find this. $80.29 meters. 80.29 meters is the length of the cable. Was it difficult? The challenge was only to imagine this thing as a rectangle. Once you have done that, you use Pythagoras theorem to solve it. Okay, so let's go ahead and do the next question. Yeah, this is straightforward, flat plate structure, no curvature, so seems easy. Let's do. A clock tower is there, and there's a pyramid on this. The edges of the pyramid is 7.5 meter. That means all the edge of this pyramid is 7.5 meters. All the edges. So that means it is something like a equilateral triangle kind of thing. So 7.5, 7.5. No, these are basically 7 because see it is on a. Oh. So you already have, it's a rectangular thing. So edges are 7.5. So let me assume that this is 7.5, this is 7.5. Now we have something called 9 over here, right? So this part will be 9. So this part is 9. Okay. We have to find this height, this one. So we need this line. Okay. So look at the pyramid. We want the slant height. Slant height can be calculated very easy, 4.5. So slant height, this L is equal to root of 7.5 square minus 4.5 square. So we will get the value of L. Let's calculate. Six. The slant height is 6. Now look at that pyramid. How much depth it is from here to here? 7 divided by 2 because that's whole thing is 7. So this is 7 by 2 and this is h. So now this height of pyramid is equal to root of slant height, which is 6 square minus 3.5 square. So this is how much? 4.87 meters. 4.87 meters. Now we very clearly know the height of pyramid is 4.87 and height of the tower is 25. So total height will be, this is 4.87, 29.87. Therefore answer is 2 nearest centimeter. So it is 29.87 meters, or we can say 29 meters 87 centimeters. That should be your answer. So here in this question, challenge was to find the height of the pyramid, and pyramid is having two different kind of dimension. One side it is 9 and the other side it is 7. So we first found the slant height and we know this is a right angle triangle here, right? So to find the height, I took half of this, which was 7 divided by 2, which is 3.5, and the slant height we knew it was 6 square minus 3.5 whole square, we got the height, and that height I added to the basic tower's height. So that's how we could do this question. Okay, I'll pause the video, note this one. Let's go ahead and do the next question. Symmetrical square base pyramid has height of 10 centimeters and slant height of 15 centimeters. Find the dimensions of the square base. So the base is a square, so it will be something like this. Square, if you see from one side, 3 dimension, it looks like this, and because the pyramid is here, so we'll join them. Okay, a little more clear. So that's our pyramid. Now the height is 10. Where is the height of the pyramid? Her height is in the center. This is the height. This they have given as 10 centimeters. Height equals to 10 centimeters, and edges are 15. All the edges are 15, and these slants are 15. Find the dimension of its square base. We don't know the dimension, so first let us put it as x. Now if I join this line, the diagonal of the square, root of x square plus x square, root of x square plus x square, x root 2, right? This whole thing is x root 2. Now how much is half of this from here to here? X root 2 divided by 2, x root 2 divided by 2. Now you have the hypotenuse, you have the height, you have this one, the base diagonal, and this height they have given as 10. So we will put in Pythagoras theorem. 15 square equals to x root 2 by 2 whole square plus height is 10 square. With this equation we will get x. The moment we will get our x, then that's the dimension and the dimensions of the square. Our task was to find the length of the square. So let us go ahead and do this. This is 225 equals to x square into 2 by 4 plus 100. This 100 comes here, it becomes 125, 2 x square by 2, this becomes 250, also x square, x is equal to root of 250. It is 5 root 10, which is equals to 15.81 centimeters. So the square base is 15.81 times 15.81. The dimensions of the square is, one of the side is 15.81, all sides are 15.81 of the square pyramid. Okay, I hope you understood this question. Pause this video and write it. Okay, let's move on to the next question. Egyptian pharaoh wishes to build a square base pyramid with all the edges of length 100 meters. Its apex will be directly above the center of its base. Now all are 100. That means the base is 100 and the slant is also 100. So once again we draw a pyramid here and we'll write the dimensions. So it's 100 by 100 square. All are 100. Even the edges of the pyramid is 100. 100, 100, all sides are 100. Wherever you see it is 100. Now they want to find the height. So height is somewhere here, isn't it? It will be at the center. This line is height. So how do we find? So by straight this you go and find the diagonal, right? 100 square plus 100 square, root of 100 square plus 100 square, which is 100 root 2. 100 root 2 is end to end. half of this is 100 root 2 divided by 2. From here to here, how much it will be? 100 root 2 divided by 2, this side, from here to here. And you know this is 100. Then height is given by root of 100 square minus 100 root 2 by 2 whole square. That is the precise height of the pyramid if all the edges of the pyramid are 100 meters. Okay, let's go ahead and calculate how much it is. 2 square. Yes. Fifty root 2, and that is 70.71. 70.71 meters. Okay, so we could calculate the height of the pyramid nearest to the meter, so it should be 71 meters. Because see, you have to read the question. No, nearest to the meter. So round it up to a meter. So 71 meters will be the height of this pyramid. Okay, so pause this video and do it yourself. You'll get it. So I think with this we have come to an end of the most advanced applications of Pythagoras theorem. All these Pythagoras applications requires your imagination to think in 3 dimensions. So making the images, 3-dimensional images in the brain and disintegrating it to form straight lines and right angles. Once you have a right angle, your Pythagoras theorem applies and you can solve any kind of question. Okay, so my suggestion is go to the website, practice questions from there, and in case of any doubts, you can always write to me on my mail ID. Okay, thank you. Good luck.